let's see why. Due to the almost unlimited variety of installation scenarios that may be encountered, the test of the equipment is based on specific mounting criteria for that test, and this provides a TRS, or test response spectrum. The TRS that is generated is then compared to the RRS, or required response spectrum, for the site-specific seismic criteria. However, it is up to the locally registered civil or structural engineer to determine the type and depth of embedment of that anchorage to accommodate the site-specific criteria. This is beyond the scope and responsibility of the manufacturer, but that of the design professional, installer, and end user. Now, add these variables to one more. The locally registered civil or structural engineer must also determine if the structure elements can accommodate the anchorage locations, type, and embedment. This is another reason this area of the installation rests not with the manufacturer, but the locally registered civil or structural engineer. As an illustration of this, let's consider a documented scenario. Does this equipment look like it was seismic qualified? At first glance, one might assume that it was not. However, upon closer examination and research, we find that the equipment was seismic qualified. Unfortunately, the installer did not confirm the structural design of the housekeeping pad with the locally registered civil or structural engineer. Thus, the equipment became inoperable after the seismic event, not due to the lack of the equipment's seismic demand withstandability, but because of the lack of coordination and confirmation of the structural elements involved. As an electrical consultant, you may feel that, well, this is the structural engineer's problem, or it's not part of my scope. However, as previously demonstrated, the applicable codes and standards make it prudent for the electrical consultant to be educated on the subject of seismic qualified equipment and work closely with the locally registered civil or structural engineer to make sure that the installation as a system is seismic qualified. Additionally, this will ensure that you meet the intent of those codes and standards and provide for safe operation of the equipment after a seismic event, so that human and property losses are kept to a minimum. Although probably not wanting to become an expert in civil or structural engineering, the knowledge of this criteria shown will aid the consultants to work closely together, as well as quickly find the data from the U.S. Geological Survey website you will need to write the seismic specification. Now let's move on to how the electrical engineering consultant can properly specify a piece of equipment on a project-specific basis and ensure it is seismic qualified for that location. Eaton provides on their seismic web page a template specification for the project-specific seismic criteria. First, note that web links are embedded to assist you to the appropriate, helpful, and useful sites to get you to the information you need fast and efficiently. After you've downloaded the software from the U.S. Geological Survey website onto your computer, you are ready to begin. You only need to download this software once. Let's take a look at the process step by step. We will use a project site, 1292 Harrison Street, located in downtown San Francisco, California, as our site-specific location for the seismic demand criteria. Let's see how we identify what seismic demand criteria we are looking for. The area highlighted in red is the site-specific demand criteria that the electrical consultant needs to ascertain and insert into the seismic specification. So let's find out how to locate this data. In the seismic specification template, click on the link for geocoder.us. Enter the address of your sample project, located here at 1292 Harrison Street in downtown San Francisco, California. Then click on the search button. You now have your confirmed longitude and latitude for the project-specific site address. You are now ready for the next step. Click on the web link in the spec that directs you to the U.S. Geological Survey website Seismic Design Values for Buildings. At this time, you will have to download only one time the Java Ground Motion Parameter Calculator. Save the application to your desktop or another convenient location. We recommend you make a shortcut on your desktop to this application for future use. Please note that you must have the website up and running for the Java application to work correctly. The Ground Motion Parameter Calculator is a standalone program that accesses data found on the website to accumulate the site-specific demand criteria you will need for the specification. Let us now launch the Ground Motion Parameter Calculator. From the drop-down menu, select International Building Code. Confirm the addition of the IBC is correct for your local area from the drop-down menu. Then, enter the longitude and latitude from the geocoder.us website. At this time, we need to determine the site classification. This step will also give you the value of FA, or the site coefficients, at 0.2 second short time period. At this time, click on the Map Spectrum button. Notice that the site classification for this address in downtown San Francisco, California, is a Site Class B. In the specification template, we can now enter these two pieces of information: the site classification as B and the site coefficients as FA equals 1.00. In the top right-hand corner, the values for the spectral response accelerations of SS and S1 are given. Enter these values in the specification template for spectral response accelerations SSGs and spectral response accelerations S1Gs. Now click on the OK button in the lower right of the screen to return to the main menu. Click on the Calculate SM and SD Values button. The Site Coefficient screen will briefly appear. Click on the OK button in the lower right corner of the Site Coefficient screen to return to the main screen, shown here. On the main screen, you will find the data you were seeking. You may scroll through the data in the box on the right to find the SDS peak response at 0.2 second value. Click on the View Spectra button to see the RRS, or Required Response Spectrum. The RRS must be less than the TRS, or Test Response Spectrum, supplied by the manufacturer on the Seismic Qualified Certificate. So let's now look at the complete spec. The area highlighted in red is what we have ascertained from the USGS website for the site-specific demand criteria for this project. The result: a manufacturer's completed Seismic Qualified Certificate with a comparative graphic of the site-specific RRS, Required Response Spectrum values, or it may contain worst-case generic values that exceed those values and the manufacturer's TRS, Test Response Spectrum. The manufacturer's TRS, Test Response Spectrum, as indicated by the top line in this graph, must be equal to or greater than the Site-Specific Demand Requirements, or RRS, Required Response Spectrum, as indicated by the lower line in the graph. The higher line must be greater than the lower line for the equipment to be seismic qualified for this project. For Eaton Seismic Certificates, additional educational installation information, please visit the Eaton Seismic website. Thank you again for your attention and interest in seismic qualified equipment.